In the quiet of space, the solar system turns with delicate precision. Planets trace their ancient circles, each orbit balanced by the sun's immense gravity, each motion a note in a vast cosmic symphony. For billions of years, this order has held, like a finely tuned clock whose gears never falter. The great gas giants spin in their immense loops, shepherding smaller worlds, while comets drift at the frozen edge, waiting their turn to fall inward. It is a fragile harmony, a structure that seems eternal, yet rests on invisible threads of mathematics and chance. But space is not empty. Beyond the veil of the sun's influence, the galaxy teems with wanderers, fragments of other stars, remnants of alien worlds, shards of forgotten collisions, drifting endlessly between suns. From time to time, one of these exiles crosses the boundary of the solar system, cutting through its delicate architecture. Such was the story of 1I, ʻOumuamua, and 2I, Borisov, harbingers from elsewhere. And now, in speculation and in science, another name enters the ledger of cosmic trespassers. 3IATLAS. It does not belong here. Its path is not bound to the sun, its origin not carved from our system's birth. It is a rogue, an interstellar messenger born in another nursery of planets, carrying the scars of a history that is not our own. Its journey through the solar system is brief, but in its passing lies a question that unsettles the quiet. What happens when a stranger brushes against the fragile balance of home? Like a stray gear thrown into a perfect mechanism, a single gravitational nudge could tilt planets, redirect comets, or stir unseen chaos. The solar system, so vast in human imagination, is in truth a fragile clockwork, and all it takes is one misstep, one visitor, to test the permanence of its design. The first signs came not from myth or imagination, but from the quiet precision of modern telescopes. In October of 2017, a faint streak of light passed across the field of the Pan-STARRS survey in Hawaii. At first it seemed ordinary, another minor object among the thousands catalogued each night. But as its path was traced, a strange truth emerged. This body was not bound to the sun. Its orbit was hyperbolic, its speed far too great to have been. Born within the solar system, it was the first confirmed visitor from another star, and it was given a name that echoed the depth of its strangeness. ʻOumuamua, the scout, the messenger. ʻOumuamua's story unsettled the scientific world. Its shape, inferred from the way its brightness fluctuated, appeared elongated, like a shard of rock or a sliver of ice tumbling end over end. It accelerated slightly as it left, as though driven not only by gravity but by some unseen hand, jets of gas, perhaps, or something more mysterious. It was here and gone in a flash, leaving only questions in its wake. Just 2 years later, in 2019, the heavens opened another window. Gennady Borisov, an amateur astronomer in Crimea, discovered a comet whose orbit too was unbound. Unlike ʻOumuamua, to eye, Borisov behaved more like a familiar comet, its tail streaming behind it, carrying within its vapor a fingerprint of alien chemistry. It was confirmation that ʻOumuamua had not been an anomaly. The galaxy was filled with wanderers, and some would inevitably find their way here. Around the same time, another object caught attention. ʻOumuamua, detected by the ATLAS survey system in Hawaii. At first it appeared to be a bright comet, but within months it fractured into pieces, dissolving in silence before it ever reached perihelion. Yet its dramatic break gave rise to speculation. Could such an object, born elsewhere and scattered by galactic tides, be the harbinger of yet another interstellar entry, a third, one day to be catalogued as 3IATLAS? These interlopers, whether real or hypothetical, carry an almost mythic weight. They are fragments of alien nurseries, debris, cast out by distant suns, shaped by histories that unfolded light years away. They remind astronomers that the solar system is not sealed, not protected by some invisible wall. It is porous, open to the tides of the galaxy. Every few decades, or perhaps centuries, one of these fragments arrives, tracing a path through the planets before vanishing again into the night. Identifying them is no small feat. To prove an object is interstellar requires careful measurement of its speed and trajectory. The orbits of bound comets and asteroids bend into ellipses. Interstellar bodies carve open hyperbolas, their velocity forever above the escape threshold. Some carry subtle accelerations, deviations caused by outgassing or forces still unexplained. To track them is to measure uncertainty itself, to chase after wanderers moving to pass for spacecraft to follow. Yet within these fleeting encounters lies a quiet revelation. The solar system is not an island. It drifts through a galaxy alive, with motion, swept occasionally by travelers from other suns. And in the shadow of each visitor comes a whisper of vulnerability, the balance of planets and orbits, so seemingly eternal, can be disturbed by what lies beyond. In the centuries before modern telescopes, comets were feared as omens. Their sudden appearance in the sky seemed to defy the permanence of the heavens. But with the rise of Newtonian mechanics, the mystery deepened into clarity. Comets, it was found, obeyed gravity's pull like all else, arcing in predictable ellipses around the sun. They belonged here. They were ours. The discovery of ʻOumuamua shattered that assurance. This was no comet bound by the sun's grip. It came from beyond and left again without hesitation, obeying only the silent geometry of interstellar space. In a single observation, the solar system was revealed not as a sealed chamber, but as a door through which wanderers could pass at will. The instruments that revealed these truths were born not of curiosity alone, but of necessity. The Panoramic Survey Telescope and Rapid Response System was designed to guard the Earth from hidden threats, asteroids that could devastate the planet without warning. Night after night, its mirrors swept the sky, capturing thousands of faint dots, each moving according to subtle laws of orbital mechanics. Among these countless ordinary objects, ʻOumuamua emerged as something extraordinary, a fragment whose trajectory carried it from a place humanity would never see. Without these all-sky surveys, such a messenger would have slipped through unnoticed, its brief visit lost forever to the silence of space. The detection of 2I, Borisov, strengthened the realization that the galaxy is not a quiet void, but a restless ocean. Here was a comet that looked familiar, its tail streaming with carbon monoxide and water vapor, and yet its chemistry bore subtle signatures of a world alien to our own. If comets are the seeds of life, carrying amino acids and organics across space, then Borisov may have been a seed flung from another garden entirely, a silent witness to planetary formation in some distant system. It suggested that the galaxy shares its building blocks across unimaginable distances, scattering them like pollen on the interstellar wind. For astronomers, this was a revelation that stretched the imagination toward questions of cosmic kinship. The speculation around 3IATLAS did not emerge from direct detection, but from the convergence of patterns. The Atlas survey in Hawaii, scanning the heavens for dangerous near-Earth objects, discovered Comet C 2019. At first it appeared brilliant, growing in luminosity as it approached the sun. Some imagined it could rival the great comets of history, a blazing spectacle visible even in daylight. Instead, the object fractured and faded, scattering into fragments too faint to see. Its disintegration raised questions. Had it been fragile because it was ancient, a relic drifting far longer than typical solar system comets? Could it have come from interstellar space, an echo of the same phenomenon that brought ʻOumuamua and Borisov. The answers were uncertain, but the possibility lingered. If another true interstellar visitor were confirmed, it might well be called 3IATLAS, honoring the survey that revealed it. These musings highlight the deepest fascination with such objects. They are time capsules of other worlds, relics formed under alien suns. Each one carries within it the fingerprints of a different chemistry, the record of a different history. Some may contain the very same frozen ices that gave rise to the oceans of Earth, but shaped in a laboratory light years away. Others may carry compounds unknown to our system, whispering of conditions humanity has never witnessed. They remind us that the solar system is not alone in its architecture. It is one among billions, each with its own shards, its own wanderers, some of which eventually stray across the void to find us. The challenge, however, lies not only in detecting them but in proving their identity. A comet seen at the edge of the solar system could be just another long-period wanderer from the Oort cloud, bound still by the sun's distant gravity. Only when its trajectory defies capture, when its velocity exceeds the escape threshold, can it be confirmed as truly interstellar. And even then, the margins of uncertainty loom large. Slight outgassing jets, fragments breaking away, or the faint push of radiation pressure can bend paths in subtle ways, blurring the line between what belongs here and what comes from beyond. Astronomers live in that tension, caught between the certainty of data and the vastness of possibilities. In every case, though, the implication remains profound. The solar system is not a walled garden. It is a drifting island in a galactic current, and the tides bring with them travelers from places unseen. Each arrival is a reminder of both vulnerability and connection, that orbits can be disturbed, that histories can intertwine, that fragments of distant worlds can one day find their way here. For billions of years, this has been the quiet reality, unseen until the present moment, when human eyes and instruments finally gained the power to notice. When the first whispers of a third interstellar visitor began to circulate in observatories and journals, the reactions were shaped by caution, as much as wonder. Astronomers, bound by the discipline of evidence, know that the sky can deceive. A comet from the distant Oort cloud, a miscalculated trajectory, even a faint push from sunlight reflecting off an icy surface, each could mimic the signature of something unbound. Initial voices urged restraint. Was this truly a messenger from another star, or merely a familiar object masquerading as one? The memory of ʻOumuamua lingered heavily in those discussions. That strange shard of rock, elongated, like no asteroid seen before, had challenged even the language of astronomy. Some described it as a cosmic cigar, others as a flattened disk, tumbling in silence as it raced away. It brightened and dimmed in a regular rhythm, suggesting bizarre proportions. Stranger still was its acceleration, a subtle deviation from gravity's pull, as though faint jets of gas propelled it, though none were visible. Its behavior sparked a divide. Some saw it as a natural fragment shaped by unknown processes, while others whispered of the possibility of something artificial, a relic of technology cast adrift in the dark. The scientific community had been left unsettled, its confidence shaken by how little could be concluded from so fleeting a glimpse. The discovery of Borisov had soothed some of that unease. Here was an interstellar object that looked, at least on the surface, familiar, a comet, with a tail glowing under the sun's warmth. Its chemistry, recorded through spectroscopy, confirmed its alien birth, carbon monoxide streaming from its nucleus in quantities unusual for solar system comets. With Borisov, astronomers could point and say, the galaxy does indeed scatter its debris between stars, and sometimes those fragments wander into our skies. The strangeness of ʻOumuamua had not been a singular apparition, but the first example of a larger truth, and yet that truth was unsettling in itself. If objects from other stars could pass through with such ease, then the solar system was not the sealed, orderly system it once seemed. It was porous, exposed to the currents of galactic migration. Interstellar wanderers were no longer myth, but measurable reality, crossing paths with planets, asteroids, and comets in delicate motion. Their rarity, once thought absolute, had collapsed into inevitability. The galaxy, in a sense, was sharing its debris with us, scattering fragments across the void like seeds cast into a field in the first reactions to 3IATLAS. Then two impulses warred quietly beneath the surface. One was wonder, the awe of receiving another fragment of a distant world, an uninvited gift from a place humanity might never reach. But alongside wonder rose unease. A body unbound by the sun moves with indifference. It obeys no familiar resonance, no established orbit, no predictable cycle. If such an object were massive enough, or if its path drew close to one of the giants, its gravity could reach across the solar system like a hand brushing delicate glass, leaving fractures that would only reveal themselves over centuries. Even the smallest tug, magnified by time, might change the fate of comets, the paths of asteroids, perhaps even the tilt of planetary orbits. This was the duality that framed early debates. Interstellar objects were knowledge bearers, time, capsules from other suns, but they were also potential threats. To hold both truths in mind was to acknowledge the fragility of home. The solar system's balance, so seemingly eternal, was not invulnerable. Its clockwork could, in theory, be disturbed by something as small as a wandering fragment from another sky. The reactions of scientists reflected not only their training and caution, but also a deeper philosophical reckoning. In a galaxy alive with motion, stability is never guaranteed, and so the first response to 3IATLAS was not triumph nor fear, but a quiet suspension between them, the recognition that the solar system, like humanity itself, lives in a state of borrowed order, one breath away from chaos should chance decide to intervene. When the first calculations of 3IATLAS's path began to circulate, the reactions were careful, measured, almost restrained. Astronomers had learned from experience that the heavens often play tricks. A trajectory that appears hyperbolic may shift back into the fold of the sun once uncertainties shrink. A fragment of the Oort cloud, stirred from its slumber by passing stars, can mimic the path of an interstellar traveler. To declare an object foreign to the solar system was to stake a claim of profound consequence, that here in the orbit of our own star drifted the material legacy of another. In those first weeks, skepticism was the guiding voice. Some argued the data was too incomplete, the margins too wide, the observations too brief. Others recalled the sudden debates that followed ʻOumuamua's detection, when even the act of naming it seemed premature. And yet, beneath the surface of restraint, there was something else, a quiet recognition that this possibility had become familiar, that the idea of interstellar trespassers no longer belonged only to speculation. ʻOumuamua itself still lingered as a ghost in these conversations. This strange body had been the first wound to the certainty that everything crossing Earth's sky belonged to a familiar origin. It was too fast, too oblique, its path uncurved by the sun's hand. For a fleeting 11 days it was visible, and then it was gone, fading back into the dark. What it left behind were puzzles that defied neat solutions. Its shape, inferred from its changing brightness, seemed stretched and improbable, tumbling as though broken from something larger. Its acceleration confounded expectation, a small but undeniable push outward, without the telltale streamers of gas that should accompany sublimation. To some, this was the subtle breath of outgassing too faint to detect. To others, it was the fingerprint of something wholly unknown. The debates did not end with observation. They spread into journals, conferences, and headlines, pulling the question into the realm of public imagination. Scientists found themselves, reluctantly, at the boundary where data and wonder blur. When Borisov entered 2 years later, it arrived like a bomb for those who sought order. This new object behaved as comets should. It shed gas, its tail glowed, its spectrum revealed frozen compounds that confirmed its alien origin. It was, in a sense, comfortingly ordinary, save for the fact that it came from beyond. Its discovery confirmed that interstellar objects exist not as rare miracles, but as inevitable phenomena of galactic life. Planets form, collide, scatter their debris into the void, and over millions of years, some of that debris drifts across interstellar gulfs until it slips into the well of another star. The solar system, no longer sealed, was revealed as a crossroads. Through it, pieces of other histories would occasionally pass, leaving traces of worlds humanity would never otherwise know. This was the backdrop against which 3IATLAS was discussed. The early reactions carried both a note of relief and a note of dread. Relief, because the appearance of a third interstellar candidate suggested that humanity had entered a new era of astronomy, one where the galaxy's messengers could be studied, catalogued, even intercepted in time. Dread, because each messenger was not bound by the sun's order. Their orbits cut across the architecture of planets and moons, indifferent to the fragile harmony that had endured for 4.5 billion years. A single massive body, on a close enough path, could reach across the solar system like a hand brushing a mobile, setting off vibrations that would ripple for millennia. Even a subtle tug, amplified over centuries, could redirect comets from the Oort cloud inward, unleashing storms of impacts on the inner worlds. The first journals to weigh in reflected this tension. Some argued for restraint, emphasizing probabilities, the overwhelming likelihood that interstellar objects were too small, too few, too brief in their passage, to alter the solar system's structure in any lasting way. Others, more cautious, raised the specter of resonance. A near pass by Jupiter, they warned, could amplify perturbations, redistributing asteroids or shifting long-period comets onto dangerous trajectories. Though remote, the possibility that such wanderers could catalyze chaos could not be dismissed outright. The debates carried the dual weight of scientific rigor and existential implication. For in these calculations lay not only numbers, but the recognition that humanity's home was not beyond the reach of galactic chance. The emotional resonance of these discussions was profound. To realize that pieces of other worlds routinely enter the solar system was to confront the porousness of cosmic boundaries. These were not distant stars observed through telescopes, but tangible fragments of alien systems, now within reach of human instruments. The thought carried both wonder and unease. Wonder, because it suggested a hidden dialogue between stars, a silent exchange of matter that connected planetary systems across the galaxy. Unease, because it revealed how fragile the solar system truly was. Its balance, though vast, could be bent by the intrusion of something born elsewhere. Its harmony tested by chance, alignments, and gravitational whispers. Thus, the first scientific reactions to 3IATLAS were marked by duality. It was a messenger of knowledge, carrying with it the potential to reveal the chemistry and structure of distant worlds. Yet it was also a reminder of vulnerability, that the solar system, so vast in human imagination, is in truth a delicate architecture, always at risk from forces that lie beyond. Scientists knew that the likelihood of disruption was small, but the possibility, however faint, could not be ignored. The solar system, like humanity itself, rests upon an illusion of permanence. Its order is not guaranteed, and in every new interstellar visitor lies a quiet reminder. Chance alone governs the boundaries between harmony and chaos. The first investigations into 3IATLAS unfolded not in the language of drama, but in the quiet certainty of mathematics. Astronomers turned to orbital dynamics, the austere geometry that governs every motion under gravity's sway. Here, equations traced the paths of planets, each one a curve sculpted by the sun's pull. Against this order, a hyperbolic intruder stood apart, its trajectory a raw incision across the closed ellipses of familiar worlds. Unlike comets bound to return, unlike asteroids forever circling within belts, an interstellar traveler carried no allegiance. It entered swiftly, cut through the system's invisible fabric, and departed into the dark once more. The contrast was stark: permanence against transience, harmony against intrusion. Computer models attempted to play out the encounter in silico, simulating the delicate ballet of gravitational pulls. In some scenarios, the visitor was little more than a shadow, brushing past without consequence. In others, its passage stirred faint tremors, minute changes in the orbits of small bodies, the kind that would grow only after centuries. The lessons of the past haunted these simulations. Astronomers remembered how Jupiter, with its immense bulk, had long scarred the trajectories of passing comets, ejecting some into interstellar space, hurling others inward toward Earth's fragile surface. If a bound planet could wield such influence, then what of a foreign mass, cutting across the solar system with no predictable rhythm? Even a fragmentary body, if large enough, could set in motion a slow cascade of instability. The attempts to reconstruct the path of 3IATLAS revealed how fragile certainty truly is in astronomy. Each observation, blurred by distance and distorted by atmospheric interference, introduced uncertainties that compounded with time. A margin of error in a telescope's data could, when projected outward, become the difference between a harmless pass and a near collision with Jupiter's domain. The further into the future the models extended, the more the possibilities diverged. A spray of fate radiating outward like shards from a broken mirror. Some paths bent safely away, others threaded close to the inner system, where the consequences could be profound. It was a reminder that the cosmos resists prediction, that beneath the elegance of Newtonian law lies a sensitivity that borders on chaos. In this uncertainty, debates took form. Could interstellar bodies destabilize the asteroid belts, where countless silent rocks wait between Mars and Jupiter? Could their passage nudge dormant comets from the Oort cloud, releasing them inward in storms that would echo for generations? To some, these were improbable fears, mathematical phantoms more than practical risks, but others warned of the chain reactions that define celestial history. A single encounter, multiplied through resonance and gravitational echoes, might not end when the visitor departs. Its legacy could stretch across millennia, unfolding as comets brighten in the night sky, or as orbital patterns drift imperceptibly toward disorder. The fear was not of the object itself, but of the amplification it might trigger. The solar system is a web stretched taut, each planet, moon, and belt in delicate balance with the others. A passing body is like a hand brushing the strings of an instrument. The vibration may fade into silence, or it may grow into a resonance that reshapes the melody entirely. Astronomers understood this duality well. In their calculations, they saw not only numbers, but potential futures, some serene, others unraveling. In every model was the same haunting recognition. The harmony of the solar system, for all its grandeur, is fragile. A single wanderer, born beneath another star, might be enough to test its endurance. The early investigations into 3IATLAS carried with them the peculiar weight of a mystery that could never be repeated. Unlike laboratory science, where an experiment may be run again, interstellar visitors offer only one performance. They appear suddenly, streaking across the darkness, and then they are gone, never to return. This impermanence lent urgency to every calculation, every telescope aimed at the sky. Astronomers knew that their measurements were not merely attempts to understand what was passing now, but efforts to preserve a fleeting truth that the cosmos would not offer again. In this way, the study of 3IATLAS became an act of both science and memory, an attempt to hold on to a visitor that the solar system itself would soon forget. The mathematics of its path revealed something: stark, hyperbolic motion, where the orbits of planets and comets bend into closed loops. Hyperbolas are open, untethered. Such a trajectory is a signature of exile, proof that this body was not born in the sun's cradle, but had wandered across the galaxy before intersecting with our skies. To astronomers, this single detail was both exhilarating and unsettling. It confirmed that 3IATLAS did not belong here, that its history stretched beyond the reach of human knowledge, yet it also meant that its time among us was brief, that the window for understanding was measured in weeks or months, not centuries. As calculations deepened, astronomers turned their gaze to the silent witnesses of history, comets. Jupiter's influence had long been etched into their orbits like scars on ancient stone. Many of these icy wanderers bear trajectories twisted by close encounters with the gas giant, their fates altered forever by a single gravitational brush. Some had been expelled entirely, their paths flung beyond the solar system's grasp. Others had been cast inward, their icy surfaces ignited into long tails as they approached the warmth of the sun. These scars were living evidence of how a single massive body could alter the destiny of countless smaller ones. The lesson was clear: gravitational encounters are not fleeting events, but acts of creation and destruction that ripple outward across eons. The question that haunted early discussions was whether 3IATLAS might play a similar role. Unlike Jupiter, it carried no permanent mass within the system, no enduring presence to sculpt orbits, but its intrusion, precisely because it was foreign, defied the predictable patterns that keep the solar system in order. If it passed close enough to an asteroid family, or near the subtle boundary of a resonance, the smallest nudge might cascade into larger changes. Over thousands of years, a chain reaction could follow asteroids shifted from stable belts into unstable paths, comets drawn from dormancy into motion. A single crossing could, in principle, seed centuries of disruption. This possibility was not idle speculation. Computer simulations, run on powerful clusters, revealed the sensitivity of the solar system to small perturbations. In some models, even a modest interloper, passing within the vicinity of Jupiter, could destabilize faint resonances between asteroids. Over time, these disturbances multiplied, scattering objects into new and sometimes dangerous trajectories. The solar system, though ancient, was shown to be less rigid than once imagined. It was a living system, responsive to nudges, and vulnerable to the stray presence of a visitor born under another sun. Yet not all agreed on the severity of the threat. Some scientists insisted that the solar system's mass, anchored by the Sun, reinforced by Jupiter and Saturn, was too great to be unsettled by a body so small. They argued that 3IATLAS, no matter its alien origin, was a mere pebble against a cosmic mountain, its influence negligible against the dominion of the giants. Others, however, pointed to the inherent unpredictability of chaos. In a universe where even the flutter of a distant comet could, by chance, redirect the fate of worlds, certainty was elusive. The debate became not only about mass and motion, but about the nature of fragility itself, about whether stability is an illusion. We tell ourselves to resist the truth of impermanence, and so the early investigations carried a dual voice, one calm, analytical, rooted in equations and probability, the other anxious, almost poetic, aware that the cosmos does not require great force to alter destiny. To some, 3IATLAS was a passing guest, destined to leave without consequence. To others, it was the faint beginning of a longer disturbance, the first note of a resonance that might echo long after its departure. What united them all was the recognition that such encounters strip away the illusion of isolation. The solar system, once imagined as a sealed sanctuary, was revealed to be part of a larger, restless sea, vulnerable, exposed, and open to the touch of wandering strangers from beyond. The first true breakthroughs in the study of 3IATLAS came not from whispered speculation, but from the steady gaze of machines designed to see what the human eye could never follow. On mountain summits and in orbit above the atmosphere, telescopes tracked the faint glimmer of the visitor against the starfield. Gaia, with its exquisite sensitivity to stellar positions, measured how the background shifted ever so slightly. As the intruder passed, the Hubble Space Telescope, a sentinel in the silence of low Earth orbit, stretched its vision toward the faint, fast-moving speck, capturing its light as though clutching at the last words of a stranger who would not repeat them. From Chile to Hawaii, ground-based observatories joined the effort, chaining together observations into a net of precision, fragile, but strong enough to hold the trajectory of something unbound. Spectroscopy became the instrument of revelation. The light of 3IATLAS, dispersed into its spectrum, carried whispers of its chemistry. Peaks and troughs on a graph revealed the fingerprints of elements and molecules, painting the portrait of matter born under another star. In those readings, astronomers traced a world's forgotten history, perhaps ices rich in carbon monoxide, perhaps silicates crystallized in the furnace of a sun long extinguished. Each photon was a fragment of memory, a chemical relic carried across interstellar night. The wonder of it was unmistakable. Here, in numbers and graphs, was confirmation that the galaxy does not isolate its children. Fragments pass from one stellar family to another, carrying the geologies of alien worlds into foreign skies. But within that wonder, a tremor of unease began to spread. As data accumulated, refinements to the object's path revealed a troubling detail. The intruder's trajectory, cut closer to the planetary orbits than initial estimates had suggested. What once seemed a distant pass now appeared more intimate, threading a path uncomfortably near the gravitational dominion of Jupiter and Saturn. This proximity raised the specter of resonance. These giants do not merely orbit the Sun, they conduct the rhythms of the solar system, shaping belts of asteroids and herds of comets into patterns of stability. A passing object, if caught in the right alignment, could amplify or distort these rhythms, shifting the cosmic music just enough to throw it off. Key. Simulations explored these possibilities with both rigor and dread. In many, nothing occurred. The intruder brushed past, leaving the system's harmony intact. Yet in others, subtle echoes appeared. Jupiter, stirred by the faintest tug, transmitted that influence outward into the asteroid belt, where resonance lines acted like strings of an instrument. A note, once steady, began to waver. The calculations suggested that in a few rare but possible scenarios, the cascade could ripple outward, dislodging dormant asteroids from their niches, nudging From the Oort cloud, the timescales were long, measured not in human lives, but in epochs. But the seed of chaos, once planted, requires only time to grow. For the scientists who labored over these revelations, the experience was not one of abstract equations alone, but of human moments etched against the glow of computer screens. In the quiet hours before dawn, researchers stared at streams of numbers arriving from telescopes half a world away. In those rows of data lay the story of an alien fragment threading its way through their home. Some felt exhilaration, as though they were witnesses to an ancient truth unfolding in real time. Others felt unease, as though the solar system's apparent invulnerability had cracked, revealing a fragility long suspected but rarely confronted. It was in those moments that the mystery of 3IATLAS became something more than a scientific exercise. It became a confrontation with chance, with the awareness that the solar system is not a fortress, but an open plain through which wanderers may cross. The harmony of planets, so eternal in imagination, is not written in permanence. Like the music of a fragile instrument, it can be played in tune for billions of years, and yet, with a single misplaced note, it can be unsettled, altered, and transformed into something unrecognizable. The pursuit of 3IATLAS soon became a race against time. The faint visitor moved swiftly, its path slipping across constellations in the span of nights. To the unaided eye, it was nothing, lost against the tapestry of stars. But to those who watched through the instruments of modern astronomy, it was a signal in constant flight. Gaia charted its position with millisecond precision, its data so fine that a shift no larger than the width of a human hair seen from 1,000 kilometers could be measured. From these details, the trajectory emerged, a curve that spoke not of belonging, but of passage. Its orbit was not the closed circle of loyalty to the sun, but the open scar of a hyperbola, a path that enters only to depart, carrying with it no promise of return. Hubble's sharp vision extended the investigation further, seizing upon light barely brighter than noise. With long exposures, its instruments revealed faint reflections that hinted at a fractured surface, jagged and irregular, as though the object had been broken long ago in the violence of another system's youth. When the light was spread into spectra, deeper truths appeared. The chemical story was unlike the familiar patterns of most solar system comets. Ratios of carbon-bearing molecules suggested conditions colder than any world orbiting our sun today, perhaps formed in the outer reaches of a star smaller and dimmer than our own. In a sense, this fragment carried the fingerprint of a vanished cradle, a frozen memory of alien beginnings. To hold that knowledge was to feel both awe and unease. Awe that such a fragment had come to us, unease that its trajectory might bring it too close to the delicate order we depend upon. As these data converged, attention turned once more to Jupiter and Saturn, the great regulators of celestial order. These worlds, vast in mass, conduct the architecture of the system like the low notes of a cosmic symphony. Their resonances keep asteroids trapped in repeating rhythms. Their gravity wells act as both guardians and executioners, capturing or flinging bodies into new orbits. Into this arrangement came 3IATLAS, an outsider with its own momentum, slipping across gravitational landscapes with indifference. Simulations revealed that if its path threaded just close enough, even without collision, its momentum could transfer subtly into the orchestra. Jupiter, fractionally moved, would in turn alter the timing of countless smaller players. Resonances might shift by imperceptible margins, but those margins, magnified across millions of orbits, could grow into vast departures. The symphony, once steady, might bend into dissonance. The possibility seemed remote, yet it could not be ignored. astronomers ran countless simulations, each seeded with slightly different initial conditions, each branching into divergent futures. In many, nothing happened. The system endured unchanged. In others, faint ripples grew. Some scenarios showed asteroids nudged from their resonant locks, spilling into chaotic orbits over centuries. Others suggested distant comets, once stable, in their deep reservoirs, drawn sunward in a slow migration that would, in some far-off age, paint Earth's skies with long, burning tails. None of these visions carried certainty, yet each was a reminder that chaos lurks, not in violence alone, but in the accumulation of tiny differences, the slow unfolding of chance in observatories. The human element of these discoveries was as striking as the data itself. Astronomers worked in quiet rooms lit by the pale glow of screens, their solitude broken only by the hum of cooling systems and the soft clicks of keyboards. Yet, in their isolation, they shared something profound, the awareness that they were among the first beings on Earth to glimpse an interstellar fragment altering the narrative of their own system. Some described the sensation as humbling, others as disquieting. The solar system, once imagined as a sanctuary of order, revealed itself instead as a fragile arrangement, its endurance never guaranteed. And in the silence of those nights, as data streamed in from orbiting satellites and mountaintop telescopes, one truth rose again and again. The cosmos is not indifferent because it is hostile, but because it is vast. The balance of worlds, the familiar rhythms of the planets, are not inevitable, only temporary. To see 3IATLAS traced against the sky was to glimpse not just a passing visitor, but the reminder that harmony is fragile, and that, in a universe alive with wanderers, the music of our solar system can never be taken for granted. The story of 3IATLAS began as a tale of motion, a line across the heavens, plotted and refined into mathematics. But soon the mystery deepened. The visitor, though distant and faint, began to behave in ways that confounded early expectations. Subtle irregularities appeared in its light curve. Brightness rose and fell not with the steady rhythm of a smooth surface rotating, but in sharp, uneven pulses, as though the body were shedding fragments, breaking itself apart under stresses. Older than the solar system itself, these suspected fragments traced fainter paths nearby, their trajectories diverging like strands unwinding from a single thread. For astronomers, the implication was unnerving. The intruder was not a single entity but a splintering presence, multiplying the uncertainties of its influence. Each fragment carried its own momentum, its own potential to perturb. Turning one object into many, spectroscopy revealed another layer of strangeness. The chemical fingerprints were unlike those of familiar comets. Certain ices seemed to sublimate at unexpected rates, vanishing into gas under the sun's light in patterns unseen among local bodies. It suggested that 3IATLAS had formed in an environment with conditions alien to the solar system, perhaps orbiting a red dwarf where ultraviolet light sculpted chemistry differently, or perhaps birthed in the shadow of a massive star whose radiation altered the building blocks of matter. The sublimation produced jets of gas that were uneven, unpredictable, small thrusters of alien chemistry nudging the object onto new paths. In this 3IATLAS echoed the enigma of ʻOumuamua, whose unexplained acceleration had provoked debate between natural and exotic explanations. Once again, astronomers found themselves confronting behavior that resisted familiar categories. These revelations revived an ancient question. What role do such wanderers play in the history of life itself? Some saw them as deliverers. In their aces and dust, interstellar objects may carry organic compounds, amino acids, carbon chains, molecules that could seed life on barren worlds. To imagine fragments of alien chemistry falling into Earth's young oceans was to imagine a universe where life does not begin in isolation, but in communion, scattered like pollen across interstellar winds. Others saw them as destroyers. A fragment large enough, crossing to near Earth, would carry not the seeds of life, but the violence of extinction. The same mechanism that spreads creation can also deliver ruin, and the same body that may gift water or carbon may erase the fragile biosphere it touches. This paradox came to define the debate. Interstellar visitors are messengers, but their message is ambiguous. They speak of a galaxy alive with exchange, where worlds are not sealed but share fragments of their being across impossible distances. Yet they also speak of danger, of chaos carried silently across the void, arriving unannounced in skies unprepared. With 3IATLAS, this duality became tangible. Its fragments hinted at instability. Its alien chemistry spoke of origins beyond human reach. Its trajectory brushed against the sanctity of planetary order. It seemed to embody both promise and threat at once. Speculation grew sharper. What if its path aligned just slightly differently, crossing near Earth's orbit? The possibility of collision was dismissed as vanishingly small, yet the imagination lingered on the scenario. A body not native to the Sun's system would strike with alien composition and unfamiliar force. Would its ices vaporize in an incandescent burst, or would its denser core carve a crater that rewrote human history? Even without impact, the approach of such a fragment might scatter debris into orbits intersecting Earth over decades, a threat seeded by a single interstellar crossing. The very act of entertaining such thoughts revealed something essential about human perspective, the tension between data and imagination. For the data told a story bounded by numbers. Observations constrained the path. Chemical signatures traced alien origins. Models predicted trajectories with margins of error. But imagination filled the gaps with narrative, with visions of creation or destruction, with stories as old as myth, but written now in the language of astrophysics. It was here, between certainty and wonder, that 3IATLAS came to rest in human thought. Not as a simple visitor, but as a paradox, a reminder that the universe does not speak in absolutes, but in mysteries that both invite and resist resolution. The weeks that followed brought a strange mixture of clarity and confusion. As telescopes tracked the fading speck of 3IATLAS, each new dataset answered one question only to unfold another. Fragmentation, once a suspicion, began to look more like certainty. Subtle trails of dust and gas hinted at a body no longer whole, but fractured, its gravity too weak to hold itself together under the stresses of interstellar travel and the warmth of the sun. Such disintegration was not entirely. Foreign comets often shed material as they near the inner solar system, but with 3IATLAS, the physics carried an unfamiliar weight. This was not simply a local object destabilized by solar heat. It was a body hardened by billions of years adrift between stars, unraveling in its first true encounter with another sun. Its decay felt like the final chapter of a journey that began before Earth had known continents, before even the solar system itself had taken shape. The chemistry of its dust complicated the picture. Spectral lines revealed traces of carbon monoxide and exotic volatiles in concentrations unusual for solar system comets. These molecules sublimated at great distances from the sun, far colder than where typical comets begin to stir. It implied that 3IATLAS had formed in a place where the cosmic cradle was colder, darker, more extreme than anything found in the orbit of Jupiter or Saturn. Perhaps it belonged once to the frozen outskirts of another planetary system, where stellar light was faint and only the most volatile ices could survive. Or perhaps it had been ejected in its infancy, flung into interstellar exile before the chemistry of its home system could fully mature. Each possibility told a different story of planetary birth, and each story reminded astronomers of how fragile, how contingent, their own solar system's history truly was. There was something haunting in the realization that Earth itself may be partially built from the remnants of such wanderers. If interstellar bodies pass through every star system with sufficient frequency, as models now suggest, then the young Earth was almost certainly struck by some delivering molecules that became folded into the architecture of life. It reframed the biosphere not as a solitary miracle, but as a chorus in a galaxy where material is shared freely, scattered endlessly, crossing gulfs that seemed to human minds almost infinite. Yet this same thought gave rise to unease. If interstellar objects have visited before, then the possibility of devastation is not a matter of if, but of when. For every messenger bearing organics, another may have arrived carrying momentum enough to shatter continents or erase entire evolutionary experiments. Life on Earth, in this telling, exists not in spite of such encounters, but because of the delicate balance between what was delivered and what was destroyed. The paradox of 3IATLAS grew sharper with each observation. Its fragmentation meant that, rather than a single trajectory, astronomers now had to consider a multitude. Tiny differences in velocity, too small to measure directly, meant that fragments could be nudged into slightly different paths, creating a family of objects rather than one. Some fragments would burn away in the solar wind, leaving behind only dust to glow faintly as it drifted. Others, if large enough, could continue for decades or centuries, crossing paths with planets, asteroids, or comets, leaving invisible scars that would only be noticed long after the intruder had gone. This multiplication of possibilities strained even the most advanced simulations. A single object had already been daunting. A cascade of fragments expanded uncertainty into a labyrinth. And yet, within this uncertainty, there was a deeper reflection. The solar system, so often imagined as stable and eternal, revealed itself as porous, vulnerable, unfinished. Every planetary orbit, every asteroid belt, every cometary reservoir is open to intrusion from the vastness beyond. The arrival of 3IATLAS was a reminder that the solar system is not an island but a crossroads, its harmony maintained not by isolation but by resilience. Its music can be disrupted, its balance shifted, its story rewritten by bodies that arrive without warning. In this, 3IATLAS became not just an astronomical curiosity but a mirror, showing humanity the fragile contingency of its cosmic home. It begins with whispers of mathematics, delicate yet devastating in their implications. Orbital chaos theory tells of a universe where certainty is fragile, where the smallest gravitational nudge can ripple outward across centuries, turning stable orbits into slow-drifting uncertainties. In this framework, 3IATLAS is not merely a passing guest, but a disturbance in a system balanced on invisible threads. The planets, moons, and countless fragments that orbit the Sun exist in a dynamic equilibrium, a harmony not eternal but conditional. A shift so small it escapes human instruments today could cascade into a different configuration centuries from now. A cosmic echo that outlives its source. History itself hints at such power. Models of planetary migration suggest that in the solar system's infancy, rogue bodies, giants of ice and rock, wandering too close to their siblings, reshaped the entire order of worlds. Uranus and Neptune may not have been born where they circle today, but flung outward by ancient gravitational skirmishes. Jupiter's immense tug may have ejected entire planets from existence, exiling them into the interstellar dark. If the solar system could be so radically sculpted in its youth, then it is no stranger to disruption. Every passing intruder, no matter how small, recalls that the clockwork of orbits is not fixed in permanence, but written in eras of shifting stability. Beneath these Newtonian mechanics lies a deeper strangeness, whispered first by Einstein. General relativity teaches that mass bends the very fabric of space-time, curving the invisible stage upon which celestial bodies move. In this light, 3IATLAS is not only an interloper in the sun's domain, but a wrinkle in the geometry of reality itself. Its presence, however slight, warps space-time just enough to alter the dance. It is a reminder that every particle of mass, no matter how humble, participates in shaping the cosmos. Even a fragment of alien ice, tumbling through the void, leaves behind a subtle signature etched in the invisible fabric of existence. And yet, some dared to imagine stranger possibilities. What if such an interstellar visitor were not cometary debris at all, but something exotic? Theoretical physics has long speculated about compact objects, primordial black holes, relics of the Big Bang itself, smaller than a mountain, yet denser than Earth. To encounter such an object would be to face a presence that defies ordinary comprehension, bending space-time not with the elegance of a comet's curve, but with the violence of a hidden abyss. Others have speculated about fragments of exotic matter, particles stable nowhere but in the furnaces of other universes. Though no evidence links 3IATLAS to such entities, the very act of speculation reminds us that the cosmos often exceeds imagination, that every discovery rests on the threshold between the known and the unknown. In thought experiments, astronomers dared to scale the scenario upward. If a fragment can disturb, what of a giant? What if instead of 3IATLAS, fragile, crumbling, no larger than a mountain, it had been a rogue planet, a wandering mass the size of Earth, or even Neptune, set loose from its parent star? Models suggest such bodies drift between stars in staggering numbers, ejected during the violent births of planetary systems. Should one pass near the solar system, its gravity could be catastrophic, tilting planetary orbits, igniting a cascade of collisions, even flinging entire worlds into interstellar exile. The fragile balance of the solar system could collapse into a new architecture, one alien to human eyes, reshaped in an instant of cosmic time. This leads to a haunting possibility, one seldom spoken but always present in mathematics. The solar system itself may not be permanent. Its harmony, so deeply assumed, could be temporary, a fleeting order in a universe where chaos is patient. Over billions of years, intruders will come. Some will graze and vanish, leaving little behind but whispers in equations. Others may strike more deeply, unraveling orbits, scattering planets, rewriting the heavens in ways no civilization could endure. Humanity measures time in centuries, yet the solar system lives in billions of years. In that scale, stability is only an interlude, a fragile chord in the endless music of change. The mystery deepens when one considers how fragile the boundary is between order and collapse. The solar system is often imagined as a fortress, the sun's gravity anchoring its planets in place with unbreakable certainty. Yet the laws of orbital mechanics reveal something different, a precarious stability maintained not by immovable chains, but by a constant balancing act. Each planet pulls on the others. Each comet leaves its whisper of disturbance. Each passing body adds its own influence to the ledger. Over short spans, these effects vanish into insignificance, but across deep time they accumulate, like ripples spreading endlessly across a pond. A single stone tossed into that pond, even a modest one, like 3IATLAS, can alter the ripples in ways that will not be felt until ages have passed, until orbits have drifted and resonances have amplified, until harmony has become dissonance. Such fragility calls to mind the ancient catastrophes etched into the solar system's history. The late heavy bombardment, some 4 billion years ago, may have been triggered by a sudden rearrangement of Jupiter and Saturn, whose shifting resonance hurled countless objects inward toward the inner planets. The scars of that upheaval still remain in the pockmarked surface of the Moon, the craters of Mars, the battered crust of Mercury. These are the fossils of orbital instability, evidence that the solar system has known chaos before and could know it again. In this light, 3I.ATLAS is not just a curiosity, but a reminder. Instability is not a forgotten relic of the past, but a potential reality of the future. Einstein's theory provides the poetry beneath the mechanics, for it teaches that gravity is not a force in the traditional sense, but the bending of space-time itself. In this framework, every mass, from the sun to a drifting fragment, reshapes the invisible fabric in which all motion unfolds. 3I.ATLAS is therefore not simply an interloper tugging on orbits, but a distortion in the stage itself. Its trajectory carves a subtle groove into space-time, an indentation that alters the pathways of nearby bodies in ways imperceptible to human senses, but real and measurable in the equations of relativity. In the silence of the void, such warping becomes its own kind of resonance, a faint but undeniable reminder that nothing crosses the sun's domain without leaving a trace. And yet, speculation pushes further into realms where evidence thins, but imagination thrives. If interstellar comets exist, then so too must their more massive kin, planets stripped from their stars, brown dwarfs adrift without companions, perhaps even the exotic remnants of phenomena humanity has yet to name. A rogue planet brushing near could shift the very framework of orbits, turning Earth's path into something elliptical and hostile, or sending ice giants tumbling outward into the cold dark. The solar system's design is not immutable. It is malleable, a temporary pattern in a universe that excels at dismantling permanence. To contemplate a rogue of such scale is to recognize that the sun's family of worlds is not invulnerable, but always at risk of revision. In these reflections lies a haunting truth. Permanence is an illusion. The solar system, with its seemingly eternal planets and predictable orbits, is only a fleeting order in a cosmos dominated by change. On the scale of galaxies, even stars wander, tugged subtly by invisible tides. Entire clusters dissolve, their symmetry erased by gravitational encounters. Why then should the solar system be spared? Its order may not endure for the entirety of cosmic history. Instead, it may be just one arrangement among countless possibilities, a temporary melody that will one day fall silent or transform into something unrecognizable. And so, 3I.ATLAS, fragile though it is, becomes a symbol of something vast. It is not merely an icy fragment crossing the sun's path. It is a reminder of impermanence itself. It embodies the idea that stability is fragile, that order is fleeting, and that the solar system, for all its grandeur, is no exception. This is the edge of science, where mathematics merges with philosophy, where astrophysics becomes indistinguishable from meditation. It is a place where scientists do not merely measure trajectories, but wrestle with the deeper truth that nothing lasts forever, not even the clockwork of worlds. In the halls of science, after the wonder and unease have quieted, reason takes its seat. Most astronomers remind the world that interstellar objects, though rare and mysterious, are not omens of destruction but travelers on fleeting paths. The probability of one straying close enough to alter the solar system's delicate balance is vanishingly small, so small that it dissolves into insignificance when set against the vast timescales of cosmic history. Statistically, 3IATLAS is no different than its predecessors. A visitor that enters, dazzles for a moment in its strangeness, and then vanishes into the deep, leaving behind no more disturbance than a ripple fades from a pond. The mainstream view anchors itself in the physics of comets. To most, 3IATLAS is simply a frozen remnant, its body composed of volatile ices and dust, sculpted in another stellar nursery and set adrift. Its strange behavior, the fracturing, the fading, the scattering of fragments, speaks less of mystery than of fragility. Comets are brittle things, prone to disintegration when sunlight reaches them after eons in the dark. The sight of its shattering is not a harbinger of chaos, but the natural fate of fragile matter exposed to the furnace of a star. It becomes, in this interpretation, a lesson not in danger but in transience, a brief illumination of alien chemistry dissolving back into obscurity. The defenders of this perspective point to the cosmic guardianship of the giant planets. Jupiter and Saturn, with their immense gravity, act as shields, sweeping up debris and deflecting wandering objects. Their resonances sculpt the solar system, redirecting potential threats into safer trajectories. In this light, 3IATLAS was never destined to sow disorder. Its path, though alien, bent beneath the invisible hands of these titans, ensuring its passage remained a harmless arc through the sun's dominion. Earth and its siblings are not entirely defenseless. They dwell beneath the protection of ancient giants whose gravity has, for billions of years, preserved the possibility of fragile life. Evidence from past encounters strengthens the sober view. 1I ʻOumuamua, though baffling in its shape and its acceleration, slipped away without leaving scars. 2I Borisov, more easily recognized as cometary in nature, burned brightly and faded into the dark with equal gentleness. They remind the scientific community that interstellar visitors, no matter how strange, have so far been little more than curiosities, threads of mystery woven into the larger tapestry of understanding. 3IATLAS, too, fits within this lineage. A frozen messenger glimpsed briefly, studied with care, and then allowed to return to the silence from which it came. In the domain of planetary defense, the priorities reflect this reasoning. Humanity's watchful eyes focus on near-Earth asteroids, the rocky fragments born within the solar system itself, far more numerous and far more likely to pose a tangible threat. Survey missions scan tirelessly for these indigenous dangers, mapping their paths, preparing for the improbable day when deflection may be required. Interstellar objects, by contrast, pass too quickly, too rarely, and too distantly to justify the same alarm. They are acknowledged, studied, and released, their risks understood as negligible compared to the ever-present hazards already within the sun's grasp. Yet even in this sober analysis, the mystery endures, for science can calculate probabilities, can model trajectories, can explain compositions, but it cannot erase the haunting resonance of chance. The vanishingly small is not zero. The improbable is not impossible. And as long as interstellar wanderers continue to cross the solar system's borders, humanity is reminded that its home is not isolated, not sealed, not immune to the wider currents of the galaxy. Each passing body, no matter how harmless in practice, carries within it the possibility of a different story, a darker echo. The mainstream view offers comfort, but beneath it lingers the knowledge that order is always conditional, and that the next visitor may not be as easily dismissed. Even within the comfort of the mainstream view, there lies an unspoken acknowledgement of scale. The universe, in its enormity, makes even vanishingly small probabilities meaningful when stretched across cosmic time. A single interstellar object is almost certain to pass harmlessly, but across millions of years, across billions of chances, the mathematics bends toward inevitability. Scientists assured that 3IATLAS itself was never a true danger, but the very fact of its arrival reinforces a deeper truth. Interstellar debris exists in abundance, and each piece is a reminder that the solar system is not sealed off, but porous, a small harbor open to the tides of the galaxy. The mainstream perspective recognizes this without alarm, translating awe into the language of statistics, placing mystery within the framework of probability. And yet, it cannot extinguish the faint unease that follows when chance itself is the only shield in describing 3IATLAS as a comet. Astronomers reduce the strange to the familiar, its fractured form, its shimmering coma, its fading trail, all mirror the behavior of comets born in the Oort cloud. It is the cosmic equivalent of seeing a foreign bird alight on a distant branch. Its plumage is unusual, its patterns strange, yet its essence is known. Spectroscopy confirms the familiar fingerprints of volatile ices sublimating into gas under sunlight. The data speaks in a recognizable dialect: oxygen, carbon, water vapor, cyanide, alien in origin, yet ordinary in nature. To those seeking reassurance, these numbers become an anchor, proof that the interstellar visitor is not exotic, not dangerous, but simply another comet passing too briefly to matter. This framing, however, does not diminish its significance. Even as a harmless wanderer, 3IATLAS is a message in motion. Every grain of dust it sheds is older than humanity, forged in a stellar nursery beyond the sun's reach. By studying it, scientists glimpse chemistry from another system, a fragment of galactic history delivered across light years. Its harmlessness does not make it irrelevant. It makes it profound. The mainstream view, though cautious and measured, still frames such objects as windows into alien origins. They are not threats, but gifts, samples delivered free of charge by the cosmos itself, carrying whispers of worlds unseen. The defense offered by Jupiter and Saturn stands as another pillar of comfort. These gas giants, ancient architects of stability, continue their silent guardianship. Simulations show that countless comets and asteroids that might once have posed dangers were redirected, consumed or exiled by their vast gravity. Without them, Earth's history may have been shaped by unending bombardment, its fragile biosphere extinguished before it could begin. The reassurance is clear. Even if interstellar objects wander near the same forces that shaped the solar systems, early violence now protect it. The giants remain on their eternal vigil, sweeping the paths clean, bending danger into safety. It is an image at once mathematical and mythic, planetary titans standing guard, ensuring life's fragile flame can endure. And yet, the scientific community does not mistake reassurance for complacency. Planetary defense agencies continue their work with vigilance. They know the greatest risks are not the interstellar rarities, but the indigenous bodies, near-Earth asteroids that share the sun's gravitational cradle. Interstellar visitors pass quickly, but asteroids linger, their orbits crossing Earth's path with repetitive precision. Thus telescopes scan the skies not for alien fragments, but for local threats, mapping their paths with obsessive care. The mainstream view does not dismiss interstellar objects, but it assigns them their proper place in the hierarchy of danger. Fascinating, yes, but not fearsome. The real peril, if it comes, will arise from within, still, in the quiet moments after data is processed, after probabilities are calculated, after reassuring words are spoken. The unease remains. The mathematics insists that the odds are negligible. But in the human mind, the knowledge of fragility persists. The solar system, for all its grandeur, is not armored against the galaxy. The improbable, stretched across eons, becomes not just possible but certain. The mainstream view soothes, but it cannot erase the haunting awareness that order itself is temporary. Each visitor is another reminder of the permeability of borders, of the truth that isolation is only an illusion. The solar system is a house with open doors, and the galaxy is full of wanderers. Among the corridors of science, there are always rooms where the light is dimmer, where certainty gives way to speculation, and where imagination stretches the boundaries of what may be possible. It is in these margins that the story of 3IATLAS takes on its most haunting forms. While mainstream astronomers see in it nothing more than a fragile cometary fragment, others dare to ask whether such visitors carry the potential not only to illuminate, but to destroy. For if fragments of alien worlds can cross into the solar system, then the exchange need not always be benign. It could, under certain alignments of chance, serve as the spark for upheaval. Some theories dwell on the duality of seeding. Interstellar objects may carry the chemistry of life, scattering prebiotic molecules into young planetary systems, fertilizing sterile worlds, but the same principle can tilt in the opposite direction. A collision, or even a subtle gravitational nudge, could instead seed instability, triggering cascades of asteroids, sending comets hurtling inward, destabilizing orbits with echoes that reverberate for millennia. In this vision, the same messengers that might sow creation also harbor within them the possibility of destruction. They become neither wholly benevolent nor wholly malicious, but agents of chance, instruments of a universe that is indifferent to the fate of any single world. The most provocative speculation arrived with ʻOumuamua. Its elongated shape, its mysterious acceleration, and its silence in every wavelength of radio observation prompted a daring proposal from Harvard astronomer Avi Loeb. Perhaps it was not natural at all, but artificial, the remnant of a probe, or the shard of a technology designed elsewhere. This hypothesis ignited both fascination and controversy, splitting the scientific community between caution and wonder. While most dismissed the idea as premature, its presence lingered like an echo. If one interstellar visitor could be mistaken for technology, might not others conceal even stranger origins? 3IATLAS, in its fragility, revealed nothing of the sort, yet its very existence kept alive the thought that the galaxy may be filled with relics not only of stars, but of civilizations. Beyond these provocations, the fringe imagines quieter dangers, subtler fates. Some models suggest that a rogue interstellar body, if massive enough, could ever so slightly disturb Earth's orbit. The change might be imperceptible in a human lifetime, but over thousands of years, the drift could alter climate, tilt the rhythm of seasons, or destabilize the thin envelope of habitability upon which civilization depends. A planet need not be struck to be undone. A small change in distance from the sun, a subtle elongation of orbit, could bring ice or fire in slow, inevitable waves. In these thought experiments, destruction comes not as an impact, but as a creeping alteration of the balance that sustains life. Others turn their eyes toward the asteroid belt, imagining cascades of chaos. A passing body might stir the delicate distribution of rocks and boulders, dislodging fragments that otherwise would have remained in silence. Once set in motion, the chain reaction could endure for centuries, a slow rain of impacts upon the inner planets. In this scenario, 3IATLAS is not the weapon itself, but the hand that tips a row of dominoes, unleashing chaos long after it has vanished back into interstellar night, At the very edge of speculation lies the wild frontier of physics. Some ask whether interstellar objects could conceal exotic matter, forms of material predicted in equations but never seen. Could a fragment of dark matter clump masquerade as a comet? Could a primordial black hole, no larger than a mountain yet denser than Earth, drift unseen, bending space-time in ways invisible until too late? The likelihood is slim to the point of vanishing, yet the allure of possibility keeps the question alive. To imagine such a visitor is to confront the profound, that the solar system may be subject not only to known forces, but to secrets still hidden in the fabric of the cosmos. It is here, at the border of science and imagination, that fascination thrives. Speculation does not claim certainty. It acknowledges mystery. The mainstream calculations soothe, but they cannot dissolve the hunger to explore the unknown. 3IATLAS, fragile though it was, becomes a canvas onto which both reason and wonder project their visions. Whether natural fragment, messenger of life, harbinger of destruction, or something stranger still, it embodies the tension that defines humanity's place in the universe, caught between knowledge and imagination, between comfort and fear, between the measured world of data and the limitless expanse of possibility. Speculation often reflects less about the cosmos itself and more about the human condition. In the twilight between data and imagination, scientists, philosophers, and dreamers confront not only the mysteries of interstellar visitors, but also the boundaries of their own comprehension. 3IATLAS serves as a mirror, inviting projection of fears, hopes, and narratives that reach far beyond the icy nucleus of a comet. For some, it becomes a seed of life, drifting across gulfs of interstellar darkness to deliver the chemistry of beginnings. For others, it is the spark of ruin, an omen of how fragile the carefully tuned architecture of the solar system truly is. In either story, it is not the object itself that terrifies, but the realization that chance alone governs the path of such wanderers, and chance is deaf to human expectation. As alternative theories stretch toward the unorthodox, the question of agency becomes inevitable. If ʻOumuamua could be imagined as a relic of technology, then 3IATLAS might stir the same possibility, even if its behavior suggests otherwise. For in the immensity of space, the very idea that a fragment could be sent intentionally, whether as a probe, a beacon, or debris cast off from unknown machinery, lingers like an ember in the collective imagination. The vastness of the galaxy ensures that human eyes have seen only a fraction of what passes through its lanes. To dismiss the extraordinary outright is to forget that every scientific revolution began as a speculation that once seemed improbable. At the same time, the darker edges of theory hold a peculiar fascination. A primordial black hole, invisible to every instrument but betraying itself through subtle gravitational signatures, could travel the galaxy as easily as a shard of ice. If such an object passed through the solar system, it would not leave scars of light, but scars in the very fabric of space-time, nudging orbits, bending trajectories, unweaving the balance that holds the planets in their slow ballet around the sun. Though the probability is nearly non-existent, the very act of imagining it is enough to stir. The mind wrestles with an unsettling truth. The universe is stranger than human expectation, and perhaps stranger than human capacity to measure. This blend of wonder and unease drives the tension at the heart of speculative science. Each interstellar visitor becomes not merely a rock of ice and dust, but a vessel for questions too vast to resolve. What forces carried it here, across light years of emptiness? Did it pass silently through other systems, observed by other minds under alien skies? Could it be that across the galaxy, civilizations stare upward at fragments like 3IATLAS, each projecting their own fears and myths upon the intruder, just as humanity does today. Such questions reveal not just the limits of astronomy, but the deep human impulse to see meaning in the void. In the end, the speculative edge is less about answers than about perspective. For even if 3IATLAS is nothing more than frozen debris, the exercise of imagining its darker or more exotic natures expands the horizon of thought. It reminds humanity that the solar system is not a fortress sealed from the rest of the galaxy, but an open stage upon which unknown actors may arrive at any time. Each arrival forces a reckoning. The solar system is temporary, fragile, and permeable. Its order is not permanent, but contingent upon the accidents of gravitational chance. And in that realization lies the haunting truth: to live within such a cosmos is to accept that certainty is an illusion, and that wonder and terror are woven together in the same cosmic thread, under the quiet dome of the night sky. Where stars burn like scattered embers across a boundless ocean, the work of discovery continues with unwavering patience. Humanity has begun to understand that its solar system is not an isolated island, but a port within a galactic sea. Into this sea drift fragments of alien worlds, silent travelers whose origins may lie hundreds of trillions of kilometers away, beyond the reach of memory. Their arrivals are brief, their paths fleeting, yet their presence lingers as a reminder of how porous the boundaries of the sun's domain truly are. From this realization arises a new urgency, the need to not only witness these wanderers, but to prepare for them. In the deserts of northern Chile, construction nears completion on the Vera C. Rubin Observatory, once known as the LSST, the Large Synoptic Survey Telescope. Its gaze will sweep across the entire southern sky night after night, collecting an ocean of data vast enough to catch the brief, flickering trails of interstellar visitors. Unlike past generations of telescopes, which depended on luck as much as precision, the Rubin Observatory is designed to leave little to chance. Its mission is to catalogue the restless sky, the asteroids, the comets, the transient flashes of light, and in doing so, perhaps capture the next messenger from another star system before it slips away. But detection alone is not enough. Within NASA and ESA, quiet conversations have transformed into detailed studies, exploring how probes might one day intercept an interstellar traveler. Concepts such as the Comet Interceptor, already selected by ESA, envision spacecraft launched in wait, poised to dart toward the first suitable object that approaches the inner solar system. More ambitious still are the designs that imagine using solar sails, ion drives, or gravitational slingshots to chase down targets moving faster than any human-built machine has ever pursued. The technical challenge is formidable. ʻOumuamua raced past at 87 kilometers per second, a velocity that left Earth's fleet of spacecraft as static as stones. To catch such an object would require a revolution in propulsion, a leap in technology, equal to the leap in imagination. This challenge has forced scientists to confront not only engineering limits, but philosophical ones. For if the solar system is part of a galactic ecosystem, then encounters with interstellar bodies are not aberrations, but inevitabilities. Some pass unnoticed. Some may carry whispers of alien chemistry, organic molecules forged in stars older than the sun. Others, by sheer chance, might pass too close, perturbing orbits, scattering debris, or sowing chaos across decades and centuries. In that recognition, planetary defense, once focused almost entirely on Earth-crossing asteroids, has begun to broaden its scope. The universe is not simply sending rocks from within the asteroid belt. It is offering enigmas from the abyss, between stars, and yet the preparations are more than defensive. Each interstellar visitor is an opportunity, a sample of material unaltered by the sun's furnace, a message in chemical form from a distant planetary nursery, the dream of capturing such matter, of holding in human hands the dust of another solar system is one of science's most profound ambitions. It would be as if a fragment of the galaxy itself had delivered itself to the doorstep of Earth. For some, this is not only science, but a philosophical act, a moment when humanity's perspective widens from planetary to galactic, from survival within one star system to recognition of participation in a far greater cosmic web. There is a quiet poetry in this new era of preparation. The same species that once looked at falling comets with fear and awe now builds machines to pursue them beyond the boundaries of home. The same eyes that once imagined the sky as eternal and unchanging now measure its subtle shifts with detectors more sensitive than myth could ever dream. Each step is a reflection of how the human story is changing, no longer confined to Earth, no longer confined to the solar system, but inching toward an acceptance of its place within the galaxy's restless tide. Even so, the question remains unresolved. Will the next interstellar wanderer be nothing more than a harmless shard of frozen gas, or something far stranger, capable of reshaping both science and imagination? The instruments are readying, the algorithms sharpening, and the probes of tomorrow wait for their quarry. Until then, the night sky holds its silence, keeping its secrets, reminding all who look upward that the solar system is not alone, and perhaps never was. The story of preparation does not unfold in isolation. It is written in observatories perched on mountain summits, in research papers quietly circulated across the digital corridors of Arxiv, and in the whispered ambitions of engineers designing technologies that border on the impossible. The Vera Rubin Observatory is not simply a telescope. It is a time machine of the present, built to reveal a dynamic universe in constant motion. With its 3.2 gigapixel camera, the largest ever built for astronomy, Rubin will image the entire visible sky every few nights. Each sweep will generate 20 terabytes of data, a deluge so vast that it can only be deciphered with machine learning and advanced algorithms. This is not the work of a lone astronomer staring at photographic plates, but of a civilization learning to watch the heavens in real time, to anticipate the fleeting appearance of messengers that cross the solar boundary from the galactic deep. These interstellar wanderers are rare, but rarity does not mean irrelevance. Models suggest that thousands pass through the solar system every year, most too faint to detect, their trails lost in the background of stars. ʻOumuamua and Borisov were only the first two caught by the sharpened eyes of a new era of astronomy. The next generation of surveys, led by Rubin, promises not merely to confirm their existence, but to catalogue them systematically, perhaps turning curiosity into routine, and routine into knowledge. Yet within that routine lurks unpredictability. For every harmless visitor that slips quietly past the sun, there remains the possibility, however slim, of one with a trajectory that brushes dangerously close to the paths of planets. For this reason, attention has turned not only to detection, but to pursuit. The ESA's Comet Interceptor mission, planned for launch in the mid-2020s, embodies this strategy. Unlike traditional probes targeted at known objects, the interceptor will wait in a holding orbit, prepared to spring toward the first suitable candidate, be it a pristine long-period comet from the Oort cloud, or, with greater fortune, an interstellar visitor. Its design is modular, consisting of multiple spacecraft capable of splitting apart to study a target from several perspectives at once. In many ways, it represents the first attempt at interstellar readiness, a technological seed that could one day blossom into more ambitious pursuits. Yet the challenge of speed looms over all such missions. An interstellar object hurtling past at tens of kilometers per second is not easily intercepted by chemical rockets. The same engines that once carried Apollo astronauts to the moon. More radical solutions must be considered. Solar sails, thin as gossamer and spanning kilometers, could catch the momentum of sunlight itself, accelerating to velocities unreachable by conventional means. Concepts like breakthrough, starshot, designed originally for interstellar exploration, envision laser-driven sails that could push gram-scale probes to a fraction of the speed of light. Though such technologies remain speculative, they point toward a future where humanity might one day not only chase interstellar visitors, but send emissaries outward, meeting them halfway in the dark between stars. The prospect forces scientists and philosophers alike to widen their frame of thought. The solar system has always been imagined as a cradle of stability, its planets locked in their patient dance. Yet the discovery of interstellar visitors suggests a cosmos that is restless, permeable, and entangled. Earth is not shielded by distance, nor isolated by the sun's gravity. Instead, it resides within a web of galactic currents, exposed to encounters as unpredictable as they are inevitable. Planetary defense, once narrowly defined as protection against near-Earth asteroids, is beginning to expand to encompass this broader vulnerability, a shift not only of policy but of worldview, and still, beneath the urgency lies wonder. To capture a piece of interstellar material, to hold it within the laboratories of Earth, would be to touch the dust of another solar system, a fragment born under the light of another star. The chemistry locked within could tell of different planetary histories, of elements forged in alien furnaces, of pathways toward life unlike any Earth has known. Such a fragment would not only answer scientific questions, but awaken a deeper awareness that the universe is not distant, but present, its artifacts passing quietly through the same skies that humans once mapped with myth. The preparations underway, telescopes scanning, spacecraft waiting, propulsion dreams expanding, are acts of humility as much as ambition. They reflect the recognition that humanity does not control the cosmos, but must learn to listen to it, to anticipate its whispers and its storms. Each effort is a testament to the fragile yet determined nature of a species that understands both its vulnerability and its curiosity. For whether the next visitor proves harmless or hazardous, ordinary or extraordinary, it will remind the world of a truth both scientific and philosophical, that the solar system is not a closed sanctuary, but a chapter in a far larger story, one written in the trajectories of wanderers that come and go like shadows cast across the light of the sun. In the stillness of space, the solar system reveals itself not as a fortress of permanence, but as a fragile symphony. The planets circle in their orbits like notes bound to an unseen score, each step measured, each resonance held in balance. For billions of years this music has played, from the birth of Earth's oceans to the rise of human thought. Yet the appearance of a wanderer like 3IATLAS reminds all who gaze upward that even the most intricate harmony can be disrupted by a single discordant tone. One stray passage through the dark is enough to threaten the order that has seemed eternal, enough to show that eternity itself may only be a fleeting illusion. In that realization lies a deeper truth. Permanence is a story told by human minds, not by the cosmos. Stars are born, they flare, they collapse. Galaxies collide, scattering their contents into new forms. The solar system, with all its stability, is not exempt from the same restless cycle. It is only a temporary arrangement of gravity and motion, destined in time to unravel. The passing of 3IATLAS, real or imagined, makes this transience visible, a whisper that the mechanisms of the heavens are not immutable gears, but delicate balances, easily nudged, easily changed. humanity finds itself caught within this paradox. On one hand, it is powerless against the vast mechanics of chance. No wall of stone, no fleet of ships could alter the trajectory of a body born beneath another star. And yet, humanity is uniquely able to imagine such encounters, to trace them with mathematics, to explore them with instruments, to give them meaning beyond their physical form. This capacity to reflect, to weave fear and awe into narrative, is itself a form of resilience. It allows human beings to stand within a universe that does not recognize them, and still find connection in its silent, indifferent grandeur. Interstellar objects, in this light, become more than threats. They are emissaries from the galactic whole, fragments of a story that stretches across billions of suns. Each one carries chemistry not of this solar furnace, but of another, perhaps formed around a red dwarf, perhaps flung out during the chaos of planetary birth. To encounter them is to be reminded that Earth does not stand apart. It is not an isolated island of life, but part of a greater sea, its fate woven into currents that flow across the Milky Way. In their passing, these wanderers awaken an awareness of belonging, an awareness that the universe is not something beyond, but something within which all existence is already entangled. And so, fear and awe reveal themselves as two sides of the same coin. To dread the possibility of destruction is also to marvel at the scale of forces that make destruction possible. To fear fragility is to recognize the unlikely beauty of the balance that sustains it. What the arrival of 3IATLAS truly offers is not certainty of threat or safety, but a reminder of the profound duality at the heart of existence, that the same universe which can undo life in an instant is the one that allows life to arise in the first place. In the end, 3IATLAS fades back into the dark, as silently as it came. Its path bends away, its fragments scatter, its light diminishes into invisibility. Yet in its absence, something remains. Not the object itself, but the haunting memory of its nearness. The thought of how close the clockwork came to breaking, how close the music of the spheres came to stumbling into silence. That memory lingers in every telescope, in every calculation, in every human thought that dares to look upward. The solar system continues its patient dance, the symphony still intact, but forever marked by the knowledge that the next note may come from elsewhere, a note that could change the song forever. Yet the fading of 3IATLAS into the abyss does not end the story. Rather, it deepens it, for in its wake lies a silence more powerful than the passage itself, a silence filled with questions that no observation can yet answer. What else drifts between the stars, unseen by human eyes? How many fragments of alien worlds wander endlessly, carrying with them the dust of forgotten histories, the chemistry of vanished oceans, the seeds of beginnings that never came to be. Each one is a story untold, a chapter written in matter rather than words, waiting for the chance encounter that will let it be read by a civilization willing to listen. The reflection this provokes is almost unbearable in its scope. Human lives are measured in years, civilizations in centuries, planets in eons, yet the cosmos is not bound by these scales. To it, the solar system is a flicker, a brief alignment of matter destined to dissolve. And if even this grand architecture is impermanent, what then of the human desire for permanence? The monuments, the records, the legacies carved into stone and memory, they too will be swept away in time, not by malice, but by the natural indifference of the universe. Interstellar wanderers are a reminder of that truth, that endurance is not guaranteed, that stability is only ever provisional. But perhaps this fragility is not a curse, but a gift. The rarity of balance makes its existence more precious. To live in a cosmos where chance alone could disrupt the harmony of planets, is to recognize that the fact of their ongoing dance is extraordinary. To awaken each day under a sky that has held steady for billions of years is to stand in the presence of a miracle, not a miracle of intention, but of improbable survival. The awareness of fragility heightens the value of every moment within it, without the possibility of rupture. The music of the spheres might be taken for granted. With it, every orbit, every sunrise, becomes an affirmation of resilience. The passage of 3IATLAS also redefines the place of humanity within the wider tapestry. It is easy to imagine the solar system as an isolated sanctuary, a self-contained stage where all of history unfolds. But the evidence tells another story. Objects from distant stars do not respect the sun's dominion. They come and go, unbidden, weaving the solar system into the greater fabric of the galaxy. Earth is not alone, nor is it shielded. It is part of an ecosystem far larger than itself, vulnerable to the same chance encounters that shape every star system across the Milky Way. To acknowledge this is to accept that the human story is not confined to Earth or even to the Sun, but is written into the broader currents of the cosmos. Fear, in this light, transforms into reverence. The possibility of catastrophe is real, but it is inseparable from the grandeur of the forces that sustain existence. The same laws of gravity that could, in theory, fling a planet from its orbit are the ones that hold Earth steady enough for life to emerge. The same chaos that scatters fragments through the galaxy is the same chaos that delivered water and carbon to the young Earth. The same cosmic accidents that threaten stability are the ones that created the conditions for consciousness to arise and reflect upon them. It is a paradox without resolution, and yet within that paradox lies the deepest form of wonder. And so when 3IATLAS vanishes into the dark, its legacy is not destruction, but awareness. The awareness that the solar system is not permanent. The awareness that human existence unfolds within a fragile, temporary arrangement. The awareness that, at any moment, the balance may be altered by forces from beyond. But rather than paralyze, this awareness awakens a clarity. It sharpens the sense of belonging, the recognition that humanity is part of a cosmic symphony still unfolding, one whose final notes remain unwritten, for long after the data is archived and the trajectories forgotten. The image persists, a lone fragment from another star, gliding silently through the solar system, brushing against the fragile harmony of its planets, and then receding into infinity. A fleeting visitor, leaving behind not scars, but questions. Questions about survival, about meaning, about the delicate balance of order and chaos that defines all things. The solar system continues its dance, but with a new voice echoing in its silence, the voice of a reminder, soft but unyielding, that nothing is forever, and that beauty itself lies in the fleeting nature of harmony, the silence that follows. The departure of 3IATLAS is almost more profound than the object itself, for in that silence the universe speaks in its truest voice, not in sound, but in absence, in the quiet reminder that what humanity has witnessed is not a singular event, but a glimpse into a larger, unending procession. Countless fragments, like it must drift unseen, relics of shattered systems, of stars that lived and died before the sun had even formed. Some may be ice, carrying frozen water from alien seas. Others may be stone, born of planets ground to dust, and perhaps a few, unimaginable in their strangeness, might carry matter so exotic that it bends the laws of physics themselves. Each one is a traveler without origin or destination, moving not with purpose but with inevitability, part of a galactic tide that knows neither beginning nor end. For humanity, The sight of such an interstellar wanderer forces a re-evaluation of permanence. The solar system, to human perception, feels immovable, the planets circling in their steady ellipses, the constellations holding their ancient forms across the night sky. Yet these are illusions born of short lives and short memories. Over eons, orbits shift, stars drift, galaxies collide. What seems eternal is only briefly stable, poised on the edge of change. 3IATLAS is a messenger of this truth, a reminder that even the clockwork of the solar system is not immune to disruption. One stray body, passing close enough, could tilt the balance, altering a trajectory, unspooling a chain of consequences that unfold over millions of years. To contemplate this is to realize that fragility is not a flaw of the universe, but its essence. And yet, within fragility, there is beauty. It is because the balance can be broken that the balance itself is meaningful. Each sunrise, each stable orbit, each quiet year free of cosmic catastrophe is a victory of improbability. The rarity of stability makes its presence luminous. For a civilization only a few thousand years into its story, the knowledge that such harmony has lasted for billions of years is staggering. Against the backdrop of instability, Earth's persistence becomes miraculous, not by design, but by chance, by the blind resilience of matter arranged in just the right way. The presence of interstellar visitors also forces the solar system into a larger frame. It is no longer a closed arena where the drama of planets and life unfolds in isolation. Instead, it is porous, open to the wider galaxy, subject to the same wandering fragments that traverse the void between stars. The Milky Way is not a distant concept but a living environment, a system of systems bound together by gravity and accident. In this light, Earth is not a fortress, but a node within a vast interconnected web. The solar system breathes the galaxy's currents, taking in wanderers, exhaling comets, exchanging matter as if part of a greater organism. To understand this is to feel both vulnerability and belonging. Vulnerability, because isolation is an illusion. Belonging, because humanity is inseparable from the galactic whole. And here lies the paradox at the heart of reflection. Fear and awe are not opposites, but twins. The thought that an interstellar object could destabilize the solar system is terrifying, but it is the same thought that evokes wonder at the scale and indifference of the cosmos. The laws that could undo Earth's stability are the very laws that gave rise to Earth in the first place. The chaos that could scatter planets is the chaos that seeded life. The accidents that threaten to erase human history are the same accidents that made history possible at all. In this, the universe is not cruel nor kind, but balanced in its indifference, a mirror in which life must search for meaning. As 3IATLAS fades, what remains is not the certainty of danger, but the persistence of questions. Where did it come? From what stellar nursery cast it adrift? What forces shattered the world it may once have belonged to? Did it pass other stars before reaching the sun? And will it pass countless more after? Each interstellar object carries a biography written in matter, in isotopes, in the scars of radiation. Yet it is a biography humanity cannot fully read. The mysteries remain locked within them, carried away on paths that stretch beyond imagination. To watch such an object slip into the void is to feel the weight of ignorance, but also the exhilaration of knowing that ignorance itself is part of the journey of understanding. In the shadow of such mysteries, humanity is revealed in its jewel. Nature, small, fragile, insignificant, yet capable of awareness, of thought, of reflection. No other species, as far as is known, pauses to wonder at the trajectory of a rock from another star. No other species constructs instruments to measure its path, to debate its origin, to weave its passage into myth and philosophy. This capacity to imagine is humanity's one form of defiance against cosmic indifference. Though powerless to alter the great forces of the galaxy, it can name them, question them, contemplate their meaning. In thought, humanity becomes larger than its scale. In imagination, it extends beyond its orbit. The solar system itself, when viewed through this lens, becomes a kind of fragile symphony. Each planet, each moon, each asteroid plays its part in a cosmic arrangement, an orchestra of matter bound by gravity into patterns of astonishing longevity. But a single stray note, a visitor like 3IATLAS, could, in principle, alter the harmony, changing the music in subtle or catastrophic ways. It is an image both haunting and sublime, a symphony playing perfectly for billions of years, yet vulnerable to disruption by a chance encounter, a discordant note that echoes across eternity. To recognize this is to hear the music more clearly, to cherish its continuity while accepting its impermanence. And so the narrative deepens. What does it mean for humanity to live within a system that is fragile? Does fragility diminish the meaning of life, or does it heighten it? Some might find despair in the idea that everything is temporary, that the solar system itself will one day unravel, yet others find liberation in it. For if nothing is permanent, then meaning must be created, not inherited. The value of existence lies not in its eternity, but in its experience. To be aware of fragility is to awaken to the miracle of the present, a miracle made no less real by its impermanence. The possibility of danger from interstellar objects also casts a new light on the concept of planetary defense. For decades, scientists have focused on asteroids within the solar system, mapping near-Earth objects, devising methods to deflect or disrupt them if needed. But interstellar visitors are different. Their speed makes interception nearly impossible. Their arrival is unpredictable. By the time one is detected, it is often already on its way out. This forces a new perspective, one that acknowledges limits, that accepts some threats are beyond control. And in that acceptance lies a humility rare in human endeavors. The recognition that not all dangers can be conquered, that some must simply be witnessed, understood, and absorbed into the human story. Perhaps, in the distant future, humanity will grow beyond these limits. Perhaps fleets of probes will be launched to intercept the next interstellar traveler, to analyze it, even to ride alongside it into the unknown. Perhaps civilizations, millions of years hence, will no longer fear such objects, but will welcome them as opportunities, as seeds of discovery, as vessels of knowledge, as messengers from other stars. But for now, the vision remains speculative. For now, the only certainty is the fragility of the present, the awareness that the solar system is more porous, more vulnerable, and more connected than once believed. This awareness changes more than science. It changes philosophy. It reframes the human position in the cosmos. Once Earth was the center of everything. Then it became a planet orbiting a star, in a galaxy of hundreds of billions of stars, in a universe of countless galaxies. Each step diminished humanity's centrality, but each step also expanded its context, weaving it into something larger. Interstellar objects, like 3IATLAS, are the latest reminder of this expansion. They reveal that the solar system is not an island but a shore, lapped by tides from across the galaxy. To live here is not to live apart, but to live connected, not central, not isolated, but integral to a greater whole. And with this comes an emotional truth. Awe and fear are two sides of the same experience. To fear cosmic fragility is to recognize its immensity. To stand in awe of cosmic beauty is to acknowledge its danger. These emotions cannot be separated. They are the essence of what it means to gaze at the stars and understand, however dimly, the forces at play. They are what drive humanity to build telescopes, to send probes, to compose theories, to imagine possibilities beyond what is yet known. Without awe, science would have no spark. Without fear, reflection would lack depth. Together, they form the twin pillars of cosmic awareness. And so, in the end, the image lingers. 3IATLAS, gliding through the solar system, brushing against the harmony of planets, and then vanishing into the infinite dark. It carries no message, no intention, no warning, yet it leaves behind something profound. It leaves the recognition of fragility, the awareness of impermanence, the paradox of fear and awe intertwined. It leaves humanity not diminished, but awakened, reminded that beauty lies not in permanence but in the fleeting, fragile continuity of a system that, against all odds, endures.